Okay, so the first one here says the circumference of a circle is the product of the number pi twice the radius. Okay, so the circumference of a circle, we can represent that by C. I'm going to use a different color here, actually. Okay, so we can represent that by C, right? So that's good. Check. It doesn't really matter what letter you use, all right? But anyway, that's a good letter to use. And then is, what does is mean? Is means what?
That is what it equals to.
Exactly, right? Is means equal. Okay, is means equal. How about product? What does product mean?
Is that like the answer after you multiply it?
Perfect, right? That's true. But yeah, but product in this case is to multiply. Okay, is to multiply. So circumference of the circle is the product of the number pi and twice the radius. So you can write it like this. This is perfectly acceptable. Or in traditional terms, it would be like 2 pi r. Okay, but they're the same thing. Okay, so very good. Check. All right, let's look at the second one. The perimeter of a square is 4 times the side length. So the perimeter, right, we can represent that as P. Okay, and perimeter just means the outside, isn't it? And perimeter means you add them. So in this case, it's the perimeter of a square is 4 times the length of a side. So we can say 4L if we want to, for representing the four lengths, or you can say 4S representing the four sides. All right. So it's not this one, but it should be this one, right? The perimeter is equal to 4S or 4L, whatever you want. The next one here says the pressure is force per unit area. So this is close. We got the force per unit area. So it's force divided by the area. All we need is the equal and then the pressure. So it's to be P is equal to F over A. Okay. This one here says kinetic energy is 1/2 the product of the mass and the square of the velocity. So 1/2 of the product of the mass and the square of the velocity. So kinetic energy, we need to represent that. So let's represent that by K. Okay. And it's equal, right, is 1/2 the product. Product means to multiply. The product of the mass and the square of the velocity. That is correct, right? It's mass times the velocity squared divided by 2. So you can write it this way, or you can write it as K is equal to 1/2 mv squared. They're exactly the same. Okay? And again, don't doubt yourself. This one says the total revenue derived from selling X dishwashers is $250 per dishwasher times the number of dishwashers sold. So this is good. 250 times X. We just need, to equal it to another letter. So total revenue we can represent as R. Okay? So R is equal to 250 times X. So you got that. Okay, any questions on here?
For the last one, would it be
Yeah.
250x times x or would it just be 250x? Because I'm pretty sure she originally said it was 250x, but I didn't know if that was right or not.
She said 250 times 250x times x.
Okay.
But I think she was representing it as the x as the times. But anyway. But
Okay.
it should be this, like 250 times x. Okay?
Okay. Yeah.
So all right, any other questions? All right, let's go ahead. Let me see. All right, it says here Betsy, a recent retiree, requires $6,000 per year in extra income. She has $50,000 to invest and can invest in B-rated bonds, paying 15% per year, or in a certificate of deposit, CD, paying 7% per year. How much money should be invested in each to realize exactly $6,000 in interest per year? Okay, so if that sounded gibberish, I encourage you to read it again and again and again until it starts to make sense. All right? So I'm going to give you some time here to kind of just process that information. Okay, so the key to doing word problems again is drawing maybe a chart or some type of organization, so organizing your material. that's the best way to solve these types of problems. Okay. So first, let's talk about or write down the two things we're talking about. Okay, so we're talking about B-rated bonds, all right, that are 15% per year, and CDs paying 7% per year. Okay, so let's write that down here. So we have the bonds, and then we have the CD. Okay, so bonds is something you can buy in advance, and it takes a long time to mature. Okay. Um, and then a CD is a type of another type of savings. This has a really good return rate, 7% per year. And so the longer you have that in this type of deposit, the more interest you'll make. Okay. So it's better than your regular savings account where you get like 0.1% return rate, okay, on your savings. So this is a huge difference. So if you have extra money that's just sitting around in a savings account, I would encourage you to put in a CD because that would make you more money instead of having in the regular savings. Or even a money market is also another alternative. So, okay. Anyway, so there's Betsy, right? She's a recent retiree and she needs an extra $6,000 in income, um, all right, um to pay for expenses. Okay. So she has $50,000 to invest. All right, so the output here, so this is the total. Okay, so you can see the outcome or total, whatever you want. All right. So um the formula we're going to be using for this is dealing with simple interest. Okay. So simple interest is equal to P times R times T. So P in this case is representing the principal. Or the money borrowed. Okay. R is representing the rate. And T is representing time. And that's per year. All right. Okay. So we're going to be using this here. This is called the simple interest formula in figuring this out. Okay. All right. So let's write this down. So before we do that, actually, so let me talk about this for a second. So let's say that I have $100, okay? And let's say that I give Lauren 60 bucks, okay? How much does Elise get out of the $100? I know this sounds simple, but hopefully you'll get the point here. So again, if I have 100 bucks, I give Lauren $60. How much does Elise get from the $100? Exactly, 40, right? Because we just did 100 minus 60, which is equal to 40 bucks. Okay? So let's do it again. Now let's say I have again still 100 bucks, and this time I give Lauren uh $30. How much does Elise get? 70 bucks. Okay? Everybody agree with that, right? So whatever we give Lauren, she gets that amount, and whatever is left over, Elise gets. Okay? So think about that in this problem. So in this case, remember she has $50,000 to invest. We don't know how much she's investing. Okay, we don't know how much she's putting in each. So let's make this one X. Okay, so this will be X here. All right. So if Betsy's putting X amount of money in bonds and she has $50,000, how much is she putting in CDs? What would that be? Just think about what we just did. How would I represent that? Perfect. Everybody agree with that? 50,000 minus X, right? So again, if I'm putting an X amount of money in bonds, then CD would be the whatever is left over, 50,000 minus X. So that's going to be our P, okay? So 50,000 minus X. Okay, that's our P. So check, right? Now we need to find the rate. So for the bonds, how much is that? What's the rate for the bonds? 15%, okay? So we need to change that to a decimal, right? So this is going to be 0.15. Okay, so the bond's 0.15. What about CD? How much is that one? 7%. So again, we have to change that to a decimal. So that's going to be 0.07. Okay, so that's our rate. So check, we got that one. And then this is what? Per year, right? So she's trying to do this and figure out how much return or how much does she need to invest in each to find out exactly, to get $6,000 per year. So in this case, it's just going to be one. Okay, so for that 1 year. Everybody okay with that? Okay. And then the outcome is, again, based off of this, she wants to make an extra 6 grand. That's not a bad deal. You're putting money, $50,000, and you're getting a $6,000 return for just sitting there. That's a good deal. Okay. So she gets an output of $6,000. Okay. All right. So then we add these guys together and we equal it to $6,000. Okay. All right. So now we just simplify this, right? We multiply and simplify. So here we're going to get 0.15x plus, and 0.07 times 1 is still 0.07, right? And then we're just going to distribute that to each term. Okay, so 0.07 times 50,000 is going to give us 3,500. And then 0.07 times x will be minus 0.07x. And it's still equal to $6,000. Okay, and then we just combine like terms. So we have 0.15, and this is minus 0.07. So that's going to give us 0.08x. And we still got the 3,500. So let's put that in the front. Okay, so we got 3,500 plus 0.08x equals $6,000. Okay, then we're going to subtract 3,500 on both sides. Okay, so that cancels. And we have 0.08x equals 2,500. Then we're going to divide everything by 0.08. Okay, and then 0.08 cancels. So that gives us looks like $31,250. Okay, so what did we just solve for? Well, let's go back. What was X referring to? Well, X here is referring to what? The bonds. So this is how much she would put in the bonds. Okay, would be $31,250. And then to find out how much she put into the CDs, well, we just need to subtract, right? So we just take $50,000 minus the bonds, and we get, looks like 18,750 bucks. Okay, so that would be our answer there. All right, so she needs to put in 31,250 bucks in bonds and $18,750 in CDs to realize $6,000 in interest per year. Okay, so this next problem here is exactly the same thing. The only difference is we need to put in, she needs an outcome of $7,000. So everything is the same. We just now need to produce $7,000. Okay? So again, this second problem here, I'm not going to go over it because it's the same thing as number one here, is the only difference is the outcome is 7,000. Okay? Okay, so let's look at this next problem. It says the manager of a store that specializes in selling tea decides to experiment with a new blend. She will mix some Earl Grey tea that sells for $5 per pound with some orange pekoe tea that sells for $3 per pound to get 100 pounds of the new blend. The selling price of the new blend is to be $4.50 per pound, and there is to be no difference in the revenue from selling the new blend versus selling the other types. How many pounds of the Earl Grey tea and orange pekoe tea are required? All right, so again, if that sounded gibberish to you, I really recommend reading it again and again until it starts to make sense. So as I mentioned before as well, that organizing the information you have is the key to solving word problems. Okay, so here, let me just write this in the, actually move this over to the bottom here. Okay. Okay, so let's go ahead and organize the material that we have. So we're talking about, so I always have on the left side, what am I talking about? What are the items I'm talking about? And on the right side of the equation, I have what's the outcome. That's how I do these things. Okay. All right. So in this case, we are talking about Earl Grey, right? And we're talking about orange pekoe. These are types of tea. I don't drink tea, so I don't know if these are good or not. Maybe you do. Okay. So let's write that down. So we have Earl Grey. And we have orange pekoe. Okay. And we have our outcome. Okay. All right. So now there are items we need to figure out here. So we need to find out the costs. Okay. And then the pounds. All right. Okay, so let's look at the costs. So how much are they wanting to sell the Earl Grey for? What does it say? $5. Good, right? So Earl Grey is for $5. What about the orange pekoe? How much is that one? $3. Perfect. Okay, and then what's the outcome? What do they want to sell it for? $5, $3. What's the outcome? $4.50. Perfect. Everybody okay with that? Right? So I have all my costs on one row. Okay. $5, $3, and $4.50. So now let's focus on the pounds. Okay. So we we don't know how much she's putting in Earl Grey or pekoe, but we do know she has 100 pounds of the new blend. Okay. So let's put X for Earl Grey and orange pekoe. How much would that be? If I have 100 pounds, how much does orange pekoe get? What would that be? So think about what we just did on the previous problem. Exactly. That would be 100 minus X. Let's see. Okay. So the output, we want 100 pounds, right? This is our 100 pounds here as well. Okay. Okay. Any questions on the setup here so far? Okay. All right. So now let's put this together. Okay. So we have 5x, right? 5 times x. Then we have the 3 times 100 minus x. and then we have 450 times 100, okay? And then we're going to add those because we're combining the Earl Grey and the Orange Pekoe. That's why we're adding them. And we want an output of 450 times 100, okay? All right, and so the rest we just solve. All right, so let's do this together because again, running out of time here. So I'm going to distribute that. Whoa, that looks crazy. Okay, so we have 5x plus, let's do it over here. We have 5x plus 300 minus 3x, and then 450 times 100 is 450. Okay, so 5x minus 3x is 2x plus 300 equals 450. And then we're going to subtract 300 on both sides. So that's gone. So 450 minus 350 is 150. Then divide both sides by 2. So X gives us 75 pounds. Okay, so what does X represent? So we go back to our chart and X represents Earl Grey. So we write Earl Grey here. Okay, and then for the Orange Pekoe, right, we have a total of 100 pounds. So we just do 100 minus the 75. So that gives us 25 pounds for Orange Pekoe. Okay, this one is dealing with physics. Uniform motion. It says a motorboat heads upstream on a river that has a current of 3 miles per hour. The trip upstream takes 5 hours and the return trip takes 2.5 hours. What is the speed of the motorboat? Assume that the motorboat maintains a constant speed relative to the water. Okay, so for this problem, we're going to use the formula distance is equal to rate times time. Distance is equal to rate times time, but I'm going to write it backwards. Okay, so it's going to be rate times time equals the distance. Okay, all right. So let's go ahead and write this here. So we have the rate, then we have the time, and then we have the distance. Okay, all right. So there's two things going on here. All right, so again, it says the motorboat heads upstream, right? So it goes upstream. Okay, and then the trip, the return trip will be going downstream, right? So the trip upstream takes 5 hours and the return trip takes 2.5 hours, right? So you go upstream and then you go downstream. Okay, all right. Okay, so do we know the rate of the motorboat? Do we know the rate of the motorboat? No, right? We don't know. That's what we're looking for, right? It says, what is the speed? What is the speed of the motorboat? We don't know. So let's write that as R. It'll be lowercase r. Okay, we don't know what the speed is. Okay. What about the time? Do we know the time? How long did it take to go upstream? What does it say? How long did it take? 5 hours. Good. And then how about the return trip? How long did that take? 2.5. Good. Okay. All right. Now I want to go back to the rate real fast. So if we're going upstream, right, I don't know if you've been on the boat before, go up the river and stuff like that. It's if you go upstream, you're going against the current, right? The current, so that means that you're going to be moving slower. So it's like going uphill, right? Gravity's pulling you down. So that means then the current is what? 3 miles per hour. So if we're going upstream, are we going to add or subtract the 3 miles per hour? What do you think? Subtract, right? Because again, we have a certain rate, but since we're going against the current, it's going to slow us down. Okay? So we're going to subtract from our rate. So it's going to be -3, right? Because again, we're going against the current. Against the current. Okay? Now, if we're going downstream, that means we're going with the current, right? So would we add or subtract the current to the speed? We're going to add. Everybody agree with that? Okay, so now the current's pushing us along. It's like, okay, we're not as working as hard, right? And you see that, right? It took 5 hours to go upstream, and it only took 2.5 to go downstream because now the current is helping them move along. Okay, so now we're just going to multiply these together. So we have 5 times r minus 3, and then 2.5 times r plus 3. Okay. Now, what do we do with that? Well, let's look at this scenario. So I'm going to do my best to make a boat. All right, here's my boat, my flag. All right, so this is my starting. This is my start. Start here. Okay, and then I finish here. Okay, so I'm starting here and then I'm finishing here, right? When I go upstream, then what? I go back downstream. So I went this direction, right? To go upstream. Then I go back to the starting position. Now I go downstream. What do you notice about the distance between the two? What's the distance between the two? What do you notice about them? They're the same. Everybody agree with that? They're the same, right? Going upstream and downstream, right? They're the same. So what do we do with these two? We're going to equal them to each other. So this is going to be 5 times r minus 3 equals 2.5 times r plus 3. Okay? And then we just solve. So we're going to distribute here. So we're going to get 5r minus 15 and 2.5r plus 7.5. Okay? Then we're going to combine like terms. So we're going to subtract 2.5r on both sides, and then we're going to add 15 on both sides. Okay, I'm running out of space, so I'll put it right here. So the 2.5r is going to cancel, and the 15s are going to cancel. So 5 minus 2.5 will give us 2.5r. And then 7.5 plus 15 is going to give us 22.5. Okay. All right. And then we divide both sides by 2.5. Okay. So R, when we do that, we'll get 9 miles per hour. Okay. And what does that mean? That's the speed of the motorboat. And that's what we're looking for. Okay, so again, let's read this note part. It says, if a job can be done in t units of time, then 1 of t of the job is done in 1 unit of time. Okay, so here again, let's organize the material here. On this left side, I'm drawing a table. I have Trent, Lois, and then together. On the first column here is talking about time to do the job, and then the second column here talking about part of the job done. Okay. So in this case, it says Trent can deliver his newspapers in 50 minutes. Okay. So time to do the job, I would write 50 here because that's how long it takes Trent to complete the job. Okay, and it says Lois, it takes her 30 minutes to do the same job route. So I put 30 here. Okay. All right. Now it says here, if a job can be done in T units of time, then 1T of the job is done in 1 unit of time. So in this case, this would be 1 over 50, right? Because it says then 1 of T of the job is done in 1 unit of time. So that will be represented as 1 over 50, and this one would represent as 1 over 30. Okay. Now we got to talk about, saying how long would it take them to deliver a newspaper if they work together? So, in this case, I don't know that, right? We don't know how long it takes them to do it together. So that's going to be X. And then this will be 1 over X as part of the job done. Okay. All right. So once we set this up, now let's put this together. So this is going to be 1 over 50 plus 1 over 30. So it's Trent's work and then Lois's work together. And it's going to equal to 1 over X. Okay. All right. So this is the type of problem we've done since day one, right? This is going to be a rational equation problem. Rational just means it's written as a fraction or fraction form. So that means we have to worry about the denominator. Okay. So in this case, we need the LCD. All right. So what will be the LCD here? Perfect, right? 150x. Everybody get that? 150x again, it's 50 times 30. I'm sorry, 50 can go into 150 and 30 can go into 150, and you still need the x as well. Okay. All right, so that means we're going to multiply each term by 150x. So I'll multiply this by 150x, 150x, and then 150x. Okay. So 150 divided by 50 is going to give us 3, and then we have the x still. 150 divided by 30 is going to give us 5, and we have the x left over still. And then we have 150, right? Because there's no 150 down here, and then the x's are going to cancel. Okay. All right. So now we rewrote this problem from a rational equation to just a simple linear equation, right? We're not dealing with any rational or any numbers in the denominator. So then we just combine like terms and then divide. So 3x plus 5x is 8x, and divide both sides by 8. Okay. And then x is going to give us 18.75. Okay, so this is in minutes, so that would be 18 minutes. Okay, how can I represent 0.75? What can I multiply that by to get the seconds? Good, right? It'll just be by 60 seconds, right? Because there's 60 seconds in a minute. Okay, so okay, so it'll be 0.75 times 60 seconds. Okay, so in that case, how many seconds would that be? 45. Very good. Thank you. Okay. So maybe 45 seconds. So in this case, it would take them to work together. It would take them 18 minutes and 45 seconds. Okay. All right. Any questions on this one?